Okay, so we were discussing subnetting under the network. So in a network, we discuss there are many devices are connected to each other, and then all the devices we recognize using what we call IP addresses. And there are two versions, IP version 4 and IP version 6. And in this particular case, we are going to focus on IP version 4. So IP version 4, or we call simply, we will say IP address. It's a 32-bit number. And then, so there are 4 8-bit numbers separated with dots, right? Now, depend on the numbers, we know we can classify those IP addresses as class A, class B, class C, class D, and class E, and so on. But mainly, if you look at class A, B, C, by looking at the first 8 bits, first octet, we can say whether it belongs to class A, class B, or class C, right? And for each of them, we discuss something called subnet mask or default subnet mask. The idea of subnet mask is we use in this one, we can say, how many, number of devices can be connected in one particular network. So usually you can connect very large number of devices in class A. Small number of devices can be connected in class C, because you have a network ID and host ID. So first one, class A, you have 8 bits, then B, class 16 bits, and then you have 24 bits. Right. Now, idea of subnetting is, I told you, simply you are going to divide into, different parts. Now, especially higher, for example, networks like class A network, you can connect huge number of devices. And sometimes it's very difficult to handle that many numbers in a network. Now, to reduce this one, usually you can do subnetting. So this is just a simple address. In this case, this is class C, and class C with the default subnet mask. That means we have 255.255.255.0. That means we have 24 bits for the network. So that's why we /24. Usually this is another format that we are going to discuss today, how we could represent default subnet mask. But when you put 24, the idea there here is we will use 24 bit for the network, right? 24 bits we have used in the default case, which means we have left with 8 bits. We can have maximum of 256 addresses, right? 256 addresses or devices possible in a class C network, right? So we have 1, 2, 4, 8, 16, 32, 64, 128, 256. It's possible, right? Now, in this particular case, you have 256 addresses, which we discussed earlier as well. I'm not going to go into details. We discussed how many, computers you can connect and so on, right? So for example, here we discussed 2 to the power 8 minus 2 host addresses, including these two, we simply say 256, but that's how we are normally. For the easiness, we will say 256. So subnet, when you divide this to 2, right? What happens when you have 256, it divides as 128 each. Now, simply what we are going to do is we simply going to borrow 1 bit from the host bit, right? So we are going to borrow 1 bit from the host bit and take it as a network. So that's why the subnet becomes 25 here. We will discuss this again, but the default subnet mask will be, right, 255, 255, 255. if I remember correctly, 192, right? We discussed this earlier. So this happens because you are going to borrow one bit from the host bits, which will divide the data set or divide the number of networks into two, like this. Okay, now what we did last time at the end, we just look at this, right? One at a time. So we know one thing when we start with the class A subnets. So the first thing you need to know, like how many bits for the network, right? So we know first 8 bits only we use for the network and remaining 24 bits for the host, right? So which means I think we can have 16 million devices you can connect in class A networks, right? So to divide this one, so you borrow a bit from the class A network, and this is what will happen. So we discuss in the start, you can have 16 million. When you borrow one bit, then you can have 8 million into 2, right? So this is like 2 into 8 million. So number of devices is still the same, but now this time you have two subnets with each you have 8 million, simple like that. Then we have 10, we are borrowing 2 bits, which means there are 4 subnets and each you have 4 million. Likewise, you can go up to 30. That means you cannot borrow everything from there because you have to left something. So in this particular case, when you borrow 22 bits, right? So this will create about 4 million, right? About 4 million subnets. And then for each subnet, you have 2 devices, right? So that's the idea that we have discussed the other day. Right. So before I continue, when you look at class B subnetworks, we know in class B, you have 14 bits for the network bits. Now, actually 16 bits, but we know the first two is 1, 0, then you can't change anything, right? Isn't it? So then, and then the remaining 16 bit is for the hosts. Again, we are reducing 2 here. I told you this. We will discuss this later on again. We will reserve 1 bit for the broadcasting address, right? And then the other one is subnet mask. I mean, like to represent the other bit. I'll come to that later on. We call network address. The first one, the very first one we'll take, that means when you have zeros, we'll say network address. And finally, we have broadcast address. Usually, that's why we subtract 2 here, right? Okay, so in this particular case, you see in the default, we have network 16-bit host bits because it's the same. So subnet mask is 255.255.0.0 bits. We have not borrowed any subnets. So actually, you don't have any subnets, although I put 1. The meaning 1 here is we have only one network, right? Not the subnets, right? We have just single, but when you borrow 1, you will create 2 subnets. You divide the network into 2 parts, right? And each you have 32,776 devices is possible, right? Similarly, class C, we know 24 network bits as well as 8 host bits. And when you borrow 1, we know that it will create 2 subsets with 126 computers. So how do you get 126? 2 to the power 7, right? 2 to the power 7 minus 2. Okay, so those are the things I think we did at the very end. So in this exercise, we are supposed to find out the class of the network, IP address, and then number of subnets and number of hosts. So the given IP address is 172.16.2.1. And the subnet mask given as 255.255.254.0. Right. Now here actually put up a table to simplify this binary numbers representative decimal numbers for the diagram B. We'll keep aside. So we know that since this is class B, right? The default mask for class B is 255.255.00. That means you have 16 network bits and 16 host bits. And then you divide, right? And the subnet mask for the given one, we have 255.255.255.40, which means we have network bits of 23 and host bits of 9. So bits borrowed is 7. And to identify number of students, we have to have 2 to the power bits borrowed. In our case, it's 128. Now then remaining 9 bits are host bits. So the number of hosts is 2 to the power 9 minus 2 is approximately, this is equal to 512 or 510. Right. Okay. Right. Let's try to do another exercise. So the second question, you are asked to create a network with 5 subnets each with at least 16 hosts. Which of the subnet mask identify the suitable subnet mask? So in this one, you are asked to create a network with 5 subnets each with at least 16 hosts. So we need to create a subnets with 16 hosts. Well, we have to find out from the given set of subnets, we have to select which one is the most suitable. So the question asks you to create 5 subnets with at least 16 hosts. So now you have given a set of subnet masks. First, identify the number of network bits and number of host bits. We'll start with that. So in this particular case, we have given 4 subnet masks, and all 4 you see 255, 255, 255. So we can assume that. So this is class C network ABC. So which means in default subnet mask, we have to have 24 bits. Now let's look at the first one. It's 255, 255, 255, 192, which means you will see we have 8 ones, 8 1, 8 ones, and in here we have 2 ones, right? Which means we have total number of 26 bits for the network bits, and the remaining we have 6 bits. From the previous equations, we know to get the number of subnets, we have to get the number of network bits, subtract with the default value to find out the number of borrowed bits. So in this case, it will be 2 to the power 2. So which will create 4 subnets. Right? And the number of hosts are, we will have host bit 6, 2 to the power 6 minus 2, 62. So we are expecting at least 5 subnets, right? So this is 4. So the first one is row. Similarly, if you calculate the second, third, and fourth answers, so we will get here 27 bits for the network, 5 bits for the host bits, which means it will create 8 subnets and it has 30 hosts. Likewise, third one, it will create 16 subnets and 14 hosts. Fourth one, it will create 32 subnets and with 6 hosts. Now, if you just look at network bits or borrowed number of bits or number of subnets, then answer will be either 2, 3, or 4. But if you look at the host, now we know we have to have at least 16. So which means third one and fourth one are incorrect because it's less than 16. So the best answer for this is answer B. Okay, so now I think we can talk about the basics since we have discussed this. So we'll look at how can we, identify, right? How can we identify, right? The network bits, right? So let's look at right. Okay. So we'll start with looking at right use of classless independent domain routing. We'll write down this and we'll again come back to look at the ranges. We have not discussed the ranges yet. So we will first talk about classless inter-domain routing, right? So let's write down this. So now we look at the subnetting, right? And before we continue, I would like to discuss this special case. This is called classless inter-domain routing, or in short, we will say CDIR. Right? So in this scheme, any number of addresses in this scheme organizations can allocate any number of it independent independent of classes as A, comma, B, comma, and C. Right. So in this scheme, right, in this representation, we don't talk about network classes as A, B, or C. Instead, we will talk about a different representation. Right. CIDR IP address. So what is this? So CIDR IP address means IP address defined without any class information. So this address consists of IP address with a number separated by a slash. I will explain what this is. This number is known as network prefix. Example, so we can put something like this. We can have 192 0.0.0 slash 24. So this number 24 represent 24 network bits. Here the number that is network prefix. Network prefix represent 24-bit 24 network bits. Okay, it's very simple. So usually you have an IP address and a slash and a number. And I told you number is a prefix. And this will represent the 24 network bits. Simple as that. Right. So let's compare the two techniques. What are the two techniques? So if you look at, right, first we look at IP address and subnet mask. Then we have CDIR. So for example, the previous one, we will represent like this: 192.0.0.0. This is the IP address. Right? And subnet mask is 255. I hope you remember 255, 255. Right. Now, in this particular case, you have 24. That means this is 0, similar to previous one. So in our case, 192.0.0.0/24. That's how it represents. Simple. So right now, the previous example we discuss in this fashion. This is very simple. What you need to remember is, so this is the IP address. This is just a number of, bits for the network. That's all you need to remember. Any questions? This one. So in this one, we are going to talk about the classless inter-domain routing, or in short, we will say CDIR. So in this scheme, it will not, depend on the classes that we have discussed earlier. So it's independent of classes, and it consists of IP address and with a number separated by a slash. So this number, we call it network prefix. Now, for example, if you take 192.0.0.0/24, so which means this number represent 24, represent the 24 network bits. So when you compare, you can write down IP address and subnet mask as 192.0.0.0. So that is the IP address, and then we have the subnet mask with the old ones, 24 old ones, and rest is 0. So which means 255.255.255.0. So let's look at another example. Let's say we have 172.16.2.1, and the subnet mask is 255.255.255.0. So let's find out what is CIDR. So which means, you know, that we have 255.255. So we have 8 and 8. You have 16. 254. Another 7. 16 plus 7. So you have 23. So in short, we can simply type IP address slash and with a number, right? So with this, we can identify the number of subnets as well as number of hosts. Right, Hariputi, we'll stop for today now.